So in this video here, we will be comparing simple versus compound interest. Now, quick example here is suppose you got $5,000, you're going to invest for 5 years at 8%, and you just want to see how much you're going to have at the end of the 5 years there. So we will go over this example in the video here. Two different ways we're going to be looking at simple versus compound interest. One, just filling out a table so you can kind of see the differences between the two. And then we'll also be looking at calculating the amount you'll have after so many years just using the formulas. So here, let's assume that you have $5,000 that you're investing at 8% interest for 5 years. We're going to do simple interest versus compound interest just so we can see the difference between the two. So we'll start out by looking at simple interest. So again, $5,000 is what you start with. So the start or year zero, $5,000, right? So now you're going to do 8% of that every year. So the main question is to figure out how much more you're going to get is what is 8% of $5,000? Well, in order to do calculations with percents, we change them to decimals. So there's 8%, 0.08 right there. Just move the decimal place over 2 spots. Of normally means multiply and 5,000, right? So we're going to do 5,000 times 8% or times 0.08. And that's going to be $400 extra that you're going to have in your account, right? So we're going to add $400 for every year. So we start with our 5,000, add 400 for the first year. So now we're at 5,400. Next year, another $400. Now we're at 5,800. Another year, another $400. Now we're at $6,200. Another $400 for another year, $6,600. Another $400, another year, $7,000 even. So there's what simple interest looks like. You're simply going to add that interest amount, in this case, $400 every year. So now let's look at compound interest. Compound interest starts out the same way, $5,000 for our start amount, 5,000 right there. And then for year one, we're going to find 8% of the 5,000. So change the percent to a decimal, 0.08, move that decimal place over 2 spots. And then we take our amount times the percentage, makes 400, same as the last time, right? With simple interest, right? Compound interest, step 1 is the same as simple interest, step 1. Okay, so we're going to go the 5,000 plus the 400, the interest amount, and we're at 5,400. Now, here's where compound interest changes from simple interest. We're not going to continue to add the 400 each year. We're actually going to compound the interest, okay? So for finding year 2, we're going to do 8% of the 5,000 plus 8% of the extra interest that we have earned, okay? So for year 2, we're finding 8% of the previous year's amount, their total amount, including the interest, right? So that's going to be 5,400 times 0.08. So that's going to be 432. And again, we're going to add the 5,400 plus the 432 to make year 2's amount be 5,832. Same idea. Now we're going to find 8% of the initial amount plus how much we've earned in interest, okay? So we're finding 8% of 5,832, right? So 5832 times 0.08. So that's going to be $466.56. And we're adding to that the previous amount, 5,832, right? So here we go. We're adding $466.56 onto that. So now at year 3, we have earned $6,298.56. So just kind of back up a little bit, look at this, kind of this pattern here. You take your initial amount or last year's amount, plus last year's 8% of last year's amount, okay? So here's last year's 8% of last year's amount there, and we're going to add to that last year's amount. So last year's amount plus 8% of last year's amount. So now following this type of pattern here, the last year's amount plus 8% of last year's amount, that's going to look like this. Now, this was that growth factor type idea that we dealt with in one of the previous videos, okay? So our growth factor is going to be the 1 is last year's amount. This 0.08, that's 8% of last year's amount. So to shorten all of this work up, instead of doing all that other work that we were doing, you can literally just multiply by 1.08 from previous years to find the next years, okay? So multiply by 1.08, and for year 5, again, multiply by 1.08. So that's kind of the shortcut method, but you do got to know that the 1 goes with the last year's amount, and then the 0.08 is last year 8% of last year's amount. So let's suppose you got $1,400 to invest for 25 years at a rate of 5% annually. So if you're doing simple interest, we can use this formula. Compound interest goes with this formula here. Now, some of these letters you may not know what they mean, so let's go ahead and break that down as well. The P stands for principal. That's your start amount. That's how much you're investing initially, okay? The R, that's going to be your rate, and that is as a decimal. And then the T, that's going to be your number of years, your time in years. So for simple interest here, A is your amount. So A equals the amount after the number of years is up equals. Now we're going to replace the P with the principal or the start amount. That's going to be 1,400. So we got a 1,400 plus 1,400 there. Next up, we're going to replace the R with the rate as a decimal. So 5% as a decimal, 0.05. Just move that decimal place over 2 spots. And then next up is the T. That's going to be your time in years. That's going to be 25. Goes there, replaces the T there. Now you just go to the calculator, 1,400 plus 1,400 times 0.05 times 25, and that's going to equal $3,150. Okay, so just as a point of reference with this, you started with 1,400. Now, if you were to double your money, you'd end up with 2,800. So this is 3,150. So that's more than double. So not bad, right? So now let's look at compound interest. Quick side note with this: if you go to like Google or something like that, and you look up the formula for compound interest, it might show this one here. This one's a lot more sophisticated than the one that we're going to use. This one you can use for annual compounding, but it also works for monthly or quarterly compounding. This one here that we're going to use only goes with annually, so a little bit simpler to use. Okay, so we'll stick with this one for now. So again, A, that's the amount that you have after the number of years is up. P goes with principal. Your start amount is 1,400, so replace the P with 1,400. Now we have the 1 plus the rate in parentheses, right? The R, that's your rate, so that's still going to be 0.05 for 5%. And then the exponent, that's the number of years. In this case, it's going to be 25 for your exponent there. Now, quick pause before we go to the calculator. If you notice, we have a 1 plus 0.05 in these parentheses. That's actually pretty easy to do in your head. It's just 1.05. And also note that when we were talking about exponential growth, 1.05 would be considered the growth factor. Okay, so when I do these in the calculator, the easy ones I just go ahead and do. So right, so it's 1,400 and then parentheses 1.05 and parenthesis, and then you do the exponent and then type in 25 for the exponent there. Now in the parentheses, if you did want to do 1 plus 0.05, you could have done that as well. So it gives us our answer here, 4,740.896, blah, 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 right? So normally when we're talking money, we're going to round to the nearest penny. So that would be 0.90 or 90 cents, right? Because the 6 makes the 9 go up 1, which makes the 8 go up 1 as well. So that'd be 90 cents there. So when we have this, you can see that this 4,700 and some change, that's actually more than triple the amount of your original investment when you compound the interest amount every year. Compared to the simple interest, which got us just over double the amount. Let's have you go ahead and try this one out on your own. Pause the video, then come on back and see how you did. So here we have $1,200 invested for 20 years at a rate of 3% annually. So with simple interest, there are actually 2 different formulas you could use. The last example, I used the top one. So for this one, I'll use the bottom one. So that way you can see it both ways. So A stands for the amount that you have after the years are up. P stands for principal. That's your start amount, 1,200. So P gets replaced with 1,200. Next up, we have the parentheses 1 plus. R, that's the rate. That's 3%. So the R gets replaced with 0.03 because we change it to a decimal. The T, that's your time in years. So that's going to be replaced with a 20. So T gets replaced with a 20 there. Now just go to the calculator, type this all in, and you get $1,920. So there's simple interest. Compound interest, compounded annually. Again, A stands for the amount. P, that's the principal, so P gets replaced with 1,200. Now we have the parentheses 1 plus. R gets replaced with the rate. So 3% is the rate. So replace the R with 0.03. And then the exponent T gets replaced with a time in years, which is 20. So T is replaced with a 20. Now, again, when you go to the calculator, you can, if you want to, just add the 1 plus 0.03, save yourself some keystrokes. Either way, 2,167.333, etc. And with money, we normally just round to the nearest penny. In this case, it would be 33 cents, right? So 2,167.33 cents. So remember, with compound interest versus simple interest, compound interest, that's where you have the amount plus like 8% of the amount. This isn't super mathematical here, but you're basically doing 1 point and then the percent there as a decimal for finding the next amount down the line there. And then we have both of our formulas that we can use. I guess there's 3 of them. Simple interest has 2 different formulas. And then this compound interest, this formula here only works for annual compounding. If you're doing monthly or quarterly, you're going to have to use a more sophisticated formula for that one there. Do make sure that these formulas make it into the formula section of your notebook. Again, I recommend like the last 10 pages or 5 pages of your notebook. That way you can just flip right back to the back of it and find where all the formulas are.